You may wonder, what about tangent to the fourth? Can we do that? And the answer would be yes. Of course we can do that. The way we could tackle it would be something like this. We could... The music has to be just the right volume to be perfect. Everything's got to be perfect. Alright, so we tackle this, we could play this game. You could say, okay, this is a tangent square of x times tangent square root of x dx. This is a famous trick again. If you got a bunch of these, try to break them up into either an odd number here, an even number there, or both evens. See what works. Sometimes one works, other things don't work. Don't be afraid to try. The last thing you want to do is be paralyzed by fear. That's the worst thing. Alright, I know there's a famous relationship between tangents and secants. In case you forgot, we've got it over here in your identity sheet. Actually, it's not here, it's on the Pythagorean ones. I'll let you pull that up. But there's a famous one that says tangent square of x is equal to secant square minus 1. So I could exchange some of these, and then I try to think one step ahead. The derivative of tangent is secant square. So if I could save some of these into secants, then I would be in good shape. Why don't we try this? I will try tangent square of x. This one I will exchange for secant squared of x minus 1 dx. Okay. And then I will have a tangent squared of x secant squared of x dx minus the integral of tangent squared of x minus 1 dx. Oh no, not minus 1. Let me erase that piece little. Yeah, that's better. And then I try to see if I can handle each of these pieces separately, or if these are easier than the original problem. And the answer is they are. This one, for example, I could do a little u sub on it. I could say u is equal to tangent of x. That would make du become secant squared of x dx, which would force this integral to be integral of u square du. This is the u square, tangent square. This is the u part, the du part right there. So there's an even exchange, and this becomes incredibly easy. This becomes integral of, not even integral. This becomes u to the third over 3 plus a constant, which of course would become tangent to the third x over 3. Of course, I've got this other thing that I've got to subtract, so now I work on this one. Tangent square x. To integrate tangent square x, I could again play the same idea here. This was equal to secant squared of x minus 1 dx, so that becomes the integral of secant squared of x plus the integral of 1 dx. And I'm using plus because if I distribute that minus, that becomes a plus. So this, and I should have a dx here on each of these. That becomes minus tangent of x. This is a basic integral. The integral of secant squared is just tangent of x. Plus 1 is x plus c. There you go, we've completed the integral. Not so bad, tangent to the fourth. And if that's fun, of course, on your own you can try tangent to the fifth. And if that's fun for you, you can try tangent to the sixth. There's no limits. There's no limit to the number of tangents you can try. This is an infinite amount of fun that you could be having for all the possible tangents. Alright, we'll see you guys here next time for a different example.